Uh, Today we will talk about the amplitude and phase under the subtopic of waves. So first of all, I am writing over here our main topic waves. So let us suppose there is a waveform. On x-axis we have time component. On y-axis we have displacement component. And if this is a sinusoidal wave like this, then amplitude A will be denoted as a maximum displacement of a particle from its mean position. At this point, we can say the energy of a particle is minimum and it has a maximum displacement from its mean position. Maximum displacement from mean position. In order to understand amplitude in detail, we can say that the amplitude A, amplitude, amplitude A of a wave, of a wave in a above figure, in figure 1, a sinusoidal waveform. The amplitude A of a wave in figure 1 is the magnitude of the maximum displacement of the elements from their equilibrium positions. Is the maximum displacement of elements from their equilibrium or mean position, from their equilibrium or mean position as the wave passes through them, as the wave passes through them. The phase of the wave is the arrangement, is the basically the phase of the wave is the argument kx minus omega t plus phi of the auxiliary term sin kx minus omega t plus phi. So depend on this, for the different phases we can also change the phase angle of the same waveform. So here we can write the phase can be denoted by argument kx minus omega t plus phi of the auxiliary term sin kx minus omega t plus phi. This we can obtain from equation 1 as follows. According to the equation 1, we have y displacement in terms of x and t. A is the amplitude, sin is a function, here kx is the angular wave number, x is a minus omega t, where omega is the angular frequency, and phi is the initial phase angle. So this whole constitute our equation 1. Now this equation also describes the state of motion as the wave swifts to a string element at a particular position x and it changes linearly with time t. It also changes linearly with time t. Now this sine function also changes with time, as we can see it from the equation. Now it will oscillating between the +1 and -1. That means we have a phase difference of pi by 2. The sine function also changes with time and it oscillating between here its extreme positive value plus 1 corresponds to a peak of the wave moving through the element corresponds to a peak of the wave moving through the element. Then the value of y at position x is a. Then the value of y, which is displacement over here at position x is a, which gives you the amplitude of a wave. Now its extreme negative value minus 1 corresponds to a value of a wave moving through the element. Then the value of y at position x is minus a. Although the amplitude is a scalar quantity and it has just positive and negative values for the positive and negative values of phase angles. Moving to the element, then the value of y at position x is minus a. Thus the sine function and the time dependent phase of a wave correspond to the oscillating of a string. Thus the sine function and the time dependent phase of a element time dependent phase of a wave corresponding to the oscillation of a string element. Corresponding to the oscillation of a string element. And the amplitude of the wave determines the extremes of the element's displacement. And the amplitude of the wave determines the extremes of the element's displacement. The constant phi is called the initial phase angle over here. The value of phi is determined by the initial displacement and the velocity of the element. At the initial displacement, we take time component t equals to 0. The constant phi is determined by the initial displacement when t equals to 0, and the velocity of the element at x equals to 0. It is always possible to choose a region where x equals to 0 and the initial instant when t equals to 0 such that the constant or initial phase angle will be 0, that means phi equals to 0. Now there is no loss of generally in working with equation 1 with phi equals to 0. It is always possible to choose origin and the initial instant when t must be 0 such that the phi will be 0. There is no loss of generally. As a note we can write that there is no loss of energy, no loss of energy, no loss, no loss. As a note we can write that there is no loss while working with or by using equation 1 with y equals to 0. That's it.